In this video, we will find the integral of x times inverse sine of x. So, this integral can be written as inverse sine of x multiplied by x dx. So, we will solve this integral by using integration by parts. So, let u is equal to inverse sine of x. So, the differential du is equal to the derivative of inverse sine of x, which is 1 upon square root of 1 minus x square multiplied by dx. And we will suppose that dv is equal to x times dx. So we will take integral of both sides. Integral of dv is v and the integral of x dx is x square upon 2. Now the formula for integration by parts is integral of u dv is equal to uv minus integral of v du. Now we put the values of all these variables in this formula. So first we will write u, which is inverse sine of x, and dv is x times dx is equal to uv. U is inverse sine of x and v is x square upon 2 minus integral of v is x square upon 2 and du is 1 upon 1 minus x square dx. Now this can be written as integral of x times inverse sine of x dx is equal to half x square. First we will write this x square upon 2 as half x square multiplied by inverse sine of x minus this 2 in the denominator can be written as half integral of x square upon square root of 1 minus x square dx. Now this integral can be written as now this minus sign can be written over here with minus x square upon square root of 1 minus x square dx, and minus half will become plus half. Now we will add 1 and subtract 1 in the numerator of this fraction. So again all the thing will remain same and we will write 1 minus x square minus 1 upon square root of 1 minus x square dx. Because 1 minus 1 is 0, so we can add or add and subtract 1. Now this fraction can be written as 1 minus x square upon square root of 1 minus x square minus 1 upon square root of 1 minus x square dx. And then we will apply integral on both the fractions. So we have integral of x inverse sine of x dx is equal to half x square inverse sine of x plus half integral of 1 minus x square upon square root of 1 minus x square dx, and then minus half integral of 1 upon 1 minus x square dx. Now this integral can be written as, first we will write all the things which will remain same, then we will rationalize the denominator and get integral of 1 minus x squared dx, and then minus half integral of 1 upon square root of 1 minus x square is inverse sine of x. Then we have half x square inverse sine of x minus half inverse sine of x plus half integral of 1 minus x square dx. So we will integrate this thing separately by using a formula that integral of a square minus x square, integral of square root of a square minus x square is equal to half x square root of a square minus x square plus half a square inverse sine of x upon a plus c. So the integral of square root of 1 minus x square dx is equal to half x. So we can see that we have a square in this formula and in the question we have 1. So the value of a square is 1, or the value of a is 1. So we will write 1 in place of a square, then plus half. In place of this a square we will write 1, then inverse sine of x upon 1 plus c. So integral of square root of 1 minus x square dx is equal to half x square root of 1 minus x square plus half inverse sine of x plus c. So our actual integral is integral of x times inverse sine of x dx is equal to half x square inverse sine of x minus half inverse sine of x plus half integral of square root of 1 minus x square dx. So we can put this integral over here. So now we have half x square inverse sine of x minus half inverse sine of x plus half, and we will write this whole thing over here. So we have half x 1 minus x square plus half inverse sine of x plus c. So we will open this bracket and we have half x square inverse sine of x minus half inverse sine of x plus 1 upon 4 x times square root of 1 minus x square plus 1 upon 4 inverse sine of x plus half c. Now we have half x square inverse sine of x. Now this minus half inverse sine of x and plus 1 upon 4 inverse sine of x can be simplified. Minus half plus 1 upon 4 is equal to minus 1 upon 4 inverse sine of x plus 1 upon 4 x times square root of 1 minus x square plus k. We can replace this constant half c by k, and k is also a constant. Now we can take 1 upon 4 and inverse sine of x common. So we have 2x square from this term, and from this term we have minus 1 plus 1 upon 4 x times the square root of 1 minus x square plus k, where k is the constant of integration, and this can also be written as 1 upon 4 2x square minus 1 inverse sine of x plus 1 upon 4 x times 1 minus x square root of 1 minus x square plus k, and this is the required answer.